Hi everyone, welcome back to the fourth video of our series Generative AI Made Easy. In this series, we are exploring generative AI concepts using social media content automation as a practical example. In the last video, we explored how to run LLMs locally, how to integrate them with N8N, and how to generate dynamic stories for our videos. In this video, we'll explore how to translate those stories into stunning images to visualize our stories. Let's get into it. Let's start by defining some of the key technical concepts in image generation. First, checkpoints. A trained model saved knowledge that define its capabilities and artistic style. Next, we have text encoders, and as their name suggests, they do translate the raw text prompts that we provide into a numerical representation that the AI model can understand. Then the clip will take those numerical representation and map them into a shared embedding space where text and images that semantically similar are located closer to each other. And then LoRA, low-rank adaptation. These are small additions that can change drastically the AI model's style, like adding specific artistic flair or a character look, without the need of retraining the whole model from scratch. Then a positive prompt, which tells the AI what we want in the image, and a negative prompt, which tells what we don't want in the image, like low quality or blurry images. Then we have samplers, which are the sculpting techniques that the AI model will use to shape the image. Over the last few years, we had so many open source image generation models. Some are original models, some are fine-tunes of those models. I'm not covering every open source model in this slide. I'm just covering some of the few popular ones. The first decent image generation model at that time, 2022, was Stable Diffusion 1.5. It outputs quality of 512 by 512, so it lacks a little bit from image quality perspective. The next decent Stable Diffusion model was released in 2023, which is Stable Diffusion XL, or SDXL for short, and it is a widely popular model between the community. It's still in use, of course, and it has a lot of fine-tunes in the internet. It has also some models derivated from it, like Pony or Illustris, which is more for anime style, or Noob AI. And then in December 2024, we had Stable Diffusion 3.5 with 3 variants, large turbo, and medium, which promises to provide better prompt adhering. We also have Flux, which provide much better prompt adhering, but in the same time, it's slightly heavy by local image generation standards. We also have Flux Schnell, which provides faster image generation. Then recently we had Chroma, derivated from Flux Schnell, that has a specific artistic style. Then finally High Dream, with 3 variants, full, dev, and fast. From my experience, it provides good prompt adhering, good image quality, and very good image lightening. Now, to compare between some of these models, we will use this image prompt of a yellow duck wearing an oversized mirrored sunglasses and a tropical flower necklace, foamy spray frozen in time as it arcs around the duck's outstretched wings. So as you can see, there are a lot of things going on here in the prompt, and we'll see which model does adhere to all of this or some of this, the quality of the generated images, and the time it took to generate those images. Or images are generated 1024 by 1024. So if we start with SDXL, it generated a 30 steps image in only 10 seconds, which calculates to 0.3 second per iteration. And from prompt adhering perspective, it missed some of the details like the flower necklace, the reflective sunglasses, and also only one of the wings is outstretched. And the image quality overall, although not bad, it's not the best. Then SD 3.5 large, it generated an image of 25 steps in 36 seconds. Overall, the image quality is much better than SDXL. We can see also the prompt adherence is better, an oversized reflective sunglasses, the flower necklace, the sun out there. However, the wings are not outstretched, so it still lacked a little bit from prompt adhering perspective. Next, for Flux Dev, it generated an image of 20 steps in 29 seconds. I think it ticked all of our prompt requirements, from the flower necklace to the outstretched wings to the oversized reflective sunglasses to the sun there. The water is freezed in time. Overall, very good quality and very good prompt adherence. Next, Flux Schnell. At only 5 steps, it generated an image in 7.5 seconds or 1.5 seconds per iteration. So similar generation speed to Flux Dev, but because it requires only 5 steps, it only took 7.5 seconds to generate the image. I think it ticked all of our requirements. Then we have Illustris, the anime style image generation. At 30 steps, it generated an image in 10 seconds. The overall quality is not bad, and I think an acceptable prompt adherence. It missed the sunset, but overall it's not bad. Next, we have Chroma. I generated an image of 30 steps in 79 seconds, so the slowest in this comparison here. However, from prompt adhering perspective, I think it did very, very good. So very good image quality and prompt adhering. I would say even better than Flux Dev in this specific case, but also it comes at a higher cost of image generation. For Hydream, I only included the fast and the dev. The fast with 16 steps, it did it in 29 seconds. And I very much like the lightning of Hydream in general. Even if we compare it to Flux or Chroma, we'll see vivid, good lightning. It also ticked all of our requirements. Then Hydream Dev, it took 41 seconds. And also very good image quality, good prompt adherence, and very stunning lightning. So that's a comparison of some of the models. As you can see, some models excels at some things. SDXL is definitely the fastest, while Chroma or Flux Dev or Hydream Dev provides very good prompt adhering with higher image quality, with the cost of higher GPU requirement and higher generation time. Now let's take a look into a couple of open source solutions that will allow us to run those images locally. The first solution is LocalAI, an all-in-one generative AI option. It supports not only image generation, but also text, audio, transcription, among other things. It is very easy to set up with minimum configuration and a model gallery that we can download model from. And most importantly, it provides an OpenAI compatible API, even for image generation, which will allow us later on to integrate it with N8N as an OpenAI image generation model. It also comes with its own downsides. It has less customization and control, and it doesn't support video generation yet, something that ComfyUI supports natively. That brings us to the second option, which is ComfyUI. It is becoming the standard for local image generation. It's supported by virtually all image and video generation model. It has a strong community support. It is a node-based workflow automation, similar to N8N to a certain degree, and that can provide advanced ways of customizing our images, whether to add upscaling or to add inpainting or outpainting. It also might present a steeper learning curve, which requires more technical knowledge, and it has no native support with N8N, although one of the community members have already created a node for that, so thanks a million to him. Let's start by LocalAI. It comes as a Docker image that we need to add to our Docker Compose. With a very simple setup, we just need to expose the GPU and provide a volume to store the cached models. Let's add it to our Docker Compose. So far we have N8N, Nginx Proxy Manager for the custom domain and SSL certificate, and Ulama to run the LLMs locally. And now we will need to add LocalAI. So let's run it. We see that the container has been created and started. And we can see here that it is running. Let's check the logs. And we see that it is now listening on port 8080. I didn't expose that port. That's because we will use Nginx Proxy Manager to provide it a custom domain and an SSL certificate. Let's do that very quickly. We go to proxy hosts. The last time created one for Nginx Proxy Manager itself and one for N8N. We'll add a new one. And we will give it a domain name of localai.myhomestack.duckdns.org. For the host name, we'll just provide its Docker name. And for the port, it's 8080. We go to the SSL and we choose the SSL we created the last time. And we enable SSL and HTTP2 support. Let's visit it now. And we see that we have access to LocalAI running locally with no models installed yet. Let's install a model. We will go to gallery. As you can see, it supports a wide range of generative AI applications. We'll choose the image generation, and we'll choose the Stable Diffusion Large. If we check the info, we'll see that it is pulling it from Hugging Face, and it is pulling the GGOF format. After the installation, we'll see that it now downloaded the SD 3.5 large model with the required files to run it. We can also check the documentation about image generation, and here it provides how to use it. It's basically OpenAI compatible, so we can just use the OpenAI endpoints. And we can provide a prompt with the size of the image. It also explains how to use negative prompting. All what we need to do is pass the negative prompt after a vertical pipe, like this. It also provides the different backends that are supported and how to run custom models. So let's do an example of custom model using the documentation provided. If we go to Hugging Face models and we choose text to image, we'll see the different models that are available in Hugging Face. Let's sort by most downloads, and you'll see that Stable Diffusion 1.5 dominated at some point, and also we see the Stable Diffusion XL. If we click there, we'll see the model card, but also we'll see fine tunes here. So we click fine tunes, and then we find here a lot of community fine tunes of the base STXL, including the Inimagine XL or the Juggernaut XL V9, a very versatile model. So let's use it. Go to Files and Versions. Then this is the file that we need to download. We click here, right click on the download button, and then do a copy link. Let's now go back to Visual Studio Code, browse the files of LocalAI, and under models, we'll see the different files that LocalAI have downloaded for SD 3.5 large to run, including a couple of clip files, the T5 text encoder, the checkpoint GGOF file itself for SD 3.5 Q4, and then finally a configuration file. So let's open that. And we'll see this is the configuration file for SD 3.5 large. Let's do a copy of this. So for that, we'll just attach to the shell of the container. We'll go to the models directory, and we'll do a copy to a file called juggernautxl.yaml. Let's refresh, and we'll see the new file created. So we open that, and we'll keep everything except the model. We'll now put the Hugging Face download link. Don't need this. And then for the name, we'll give it a different name. We can name it Juggernaut XL. And we need to restart the container now. If we check the logs, we'll see that LocalAI have already started downloading the model. So it will take a little bit of time until the full model is downloaded, and then we can use it. We can see now that the model has been downloaded. And if we check now LocalAI, we'll see that we have both models, the one that we downloaded from the gallery and the one that we created manually. Let's run it. Either click here or generate images. And we can choose the model, either Juggernaut or ST. And we'll provide prompt as an astronaut cat. And we can check in the task manager that the model is being loaded. And we have already got an image of an astronaut cat. Now, of course, this is not the way that we want to generate images. So let's go to N8N and let's create a new workflow. We'll provide it any trigger, doesn't matter. Let's start with manual. And for the next node, we will choose AI, OpenAI. And for the actions, we will choose create an image. We need to create a new credential for LocalAI. So for the API key, we can put any text. And for the base URL, I will just provide it as an HTTP, then put the container name, and then the port. Let's click save, and as we can see, the connection is successful. And let's provide it a meaningful name. We will call it LocalAI, and hit save. For the model name, by default, OpenAI has 3 models, the DALL-E 2, 3, and the newest GPT image 1. But for our local creation, we'll need to get the model as it is specified here, either Juggernaut XL or SD 3.5 large GDML. So if we go back to N8N, we can do expression, and then we can put Juggernaut XL, and then we provide a prompt, let's say, for example, an astronaut cat, and try. And we can see that we got an image. We can view the image, and that's the astronaut cat. Or we can do even simpler than that. Instead of calling it Juggernaut XL, we'll call it, as it's shown here, DALL-E 3 or DALL-E 2, or we can also use the new one as GPT Image 1. So let's do that. Instead of Juggernaut XL, we'll call it DALL-E 3, for example. Save, and then we need to restart the container. You can check the logs. And we'll see that it now loads the model with the name of DALL-E 3. So let's go back to N8N. And this time we'll choose directly from here DALL-E 3 and click execute. And we'll see in the task manager that the model is being loaded and the image is being generated. And we got our image. And then as the documentation states, if we want to add a negative prompt, we just need to add the vertical line and then the negative prompt. The second option, which is ComfyUI, we have multiple installation options, either using the desktop installer, which is the easiest way to get started. We can also install it as a portable package, which gets the latest commits faster than the desktop version. And all what we need to do is to download this package and export it in any directory we want. And it has everything needed at ComfyUI, including Python and everything else. Finally, we can also use a Docker container. It's not an official image from ComfyUI. We can use it to run ComfyUI in a Docker container, especially if we run custom nodes that run Python on our systems. It's better to isolate it from our own hosts. But for the purpose of this series, we will use the desktop installer because it's simpler to install. So all what we need to do is to download the Windows installer if you are using Windows and to do the installation. When you first open ComfyUI, you will see a workflow like this, which might seem complicated, but it's not really. It is a node-based workflow similar to N8N. So we'll have multiple nodes, each leading to the next from left to right. We'll start with loading the checkpoint. That's the AI model like Juggernaut or SD 3.5. And then we'll have the positive prompt and negative prompt. We can also customize their names here to have it more clear to us. And we can also give it some colors to help visually clarify the intent of each of them. For a text to image, we will provide an empty latent image. For an image to image, we will provide an actual image converted to a latent space and then send it to the KS sampler. And all of those are connected to the sampler. And then we will decode that latent space into an image, and then we can save the image or visualize it. Luckily, ComfyUI comes with a wide range of templates that we can use without specific knowledge. So let's check some of those. We go to Workflow, then Browse Templates. And here we will see a list of templates. From the basics to Flux as an image generation model, to image with High Dream, for example, or SDXL, or SD 3.5. It has also a big list of workflows for video generation that we'll explore in a later video. And recently it starts supporting image and video generation through API nodes, basically leveraging SaaS solutions like Kling to run videos or images. Let's check, for example, the High Dream Fast workflow. ComfyUI will first check if we have the files required to run the model. In this case, we need the High Dream Fast FP8 file. Because we don't have it, it will ask us to download it. So let's go ahead and download it. Once the files are downloaded, we can check the workflow. First, we will need to load the diffusion model. Then we will need the clips and the text encoder. And then finally, we will load the VIE. We'll also load an empty latent because we are doing text to image. Pass all of that to the sampler. And then finally, we will decode the image and show it here. So let's give it a try with a prompt of an astronaut cat. Run. We can check the generation detail from here. And we can see the image that it has generated. We can also use a LoRA or low rank adaptation to customize the original models further without the need of retraining them from scratch. And it's very similar to the previous workflow. We'll need to load the checkpoint, but this time we'll need to pass both the model and the clip through one LoRA loader or multiple if we want to chain multiple of them, and then pass them to the text encoder and to the key sampler. And then the rest is the same through the VAE decoder and then save the image. You might ask how to get the LoRAs, and one place to get them is from Hugging Face. Under the text to image, we can find, for example, Flux1Dev. And we can find here fine-tunes, that's a complete retraining of the model. Or we can find a list of adapters, including LoRAs. Like, for example, this one to change to more of a Ghibli style, or this one to provide a pixel art style. This is an example of workflow that I'm using with a custom LoRA loader. Let's take this as an example to create a cute cat without any LoRAs. We got this picture here. And with a less tuned setting, we can see that we have now a more fluffy cat with a lot detail like a jungle and a very detailed eyes, for example. Now, in order to integrate ComfyUI with N8N, we'll need to do a couple of things first from ComfyUI and settings, Comfy. We'll need to enable dev mode, which will allow us to save the workflows as API and also to interact with ComfyUI using APIs. Also, we'll need to go to the server config, and here by default we find the 127 IP address, change it to your local IP, and then put a port to listen to. Any available port should do. And once we do that, we can now see an option to export the workflow for API. So we do that, we give it a name, and then we save it. If we check that file, we'll see that the whole workflow has been saved as a JSON, including the prompt that we provided, the text input, as well as the different LoRAs that we have configured. From N8N, we need to go to the settings, and then community nodes, and then click install, and then browse, and then search for ComfyUI. And this is the one. It provides access to ComfyUI directly from N8N, developed by one of the community members, so many thanks to him. We copy the name and go back to N8N, paste the name, and then click understand the risk, and then install. Once ComfyUI is installed, let's go back to previous workflow. Let's add a new one. And this time, let's search for ComfyUI. You will see that it is a community node. And then add workflow. First, we need to create the credentials, and we'll put our IP address. Click Save, and we see that the connection is successful. And then here, we need to paste the whole JSON workflow that we have copied earlier. So we go here and copy the whole thing and paste it here. We'll specify the quality as 100. And let's test it. And here is our image with the LoRAs that we set. And now we can use it directly from ComfyUI. To change the prompt, we need to provide the text here directly in the JSON. And then that will provide us with a new picture if we want to. Now, if you remember from the last video, we have created this section here for dynamic storage generation. We started with a form. We'll have a topic, and then a language, an optional one. And then this time we will add multiple image generation models from SDXL to Flux to HiDream to Illustris, but also we'll add the LocalAI option as well. So let's test this one. We put English, and we choose, for example, Flux, and then click Generate Video. Close this one, and now let's spin this. Let's run the storage generations. Now, if you remember, the output of the last node will include the visual scenes. This is what we will convert now into images. We will have 6 of them. Each has a character and the scene description. We'll need this for character consistency between the different scenes. Now, this is the new section. We will first create a temporary folder to save the images. It's a simple script. I will include it, of course, in the workflow. It will get the current date year, month, day, hours, and minute, put them into this format here, and then create a folder under the /videos. If you remember, when we self-hosted N8N, we specified to create a folder called videos that is mapped to our home stack /video. This is basically going to be our working directory to generate images and videos. And then we will return the folder name that we have created. So let's give it a try. We'll see it created a folder with the current date and time. We can check also here in Visual Studio Code and the videos. We'll see that we have now a new folder with the current date and time. We will then have another node called split out. This will take the input of the visual scenes, the output, and will split it into multiple streams or multiple outputs. You will see that this node has two inputs from the temporary folder as well as the visual scenes. And that's because we don't want to start generating any images until we first create a temporary folder and then go into the loop. So let's test this step. And you will see now that we have 6 outputs instead of a single one. So basically it split the JSON input into multiple outputs. If we check here, we'll see that we have 6 items out of the split out node. Those will be passed to a loop over items node. And as the name indicates, it will loop over each of these 6 items that we are getting. Then we are passing that into a switch. Depends on the choice of the user. If he chose LocalAI or SDXL or HiDream or Illustrious, it will output to the right node. You can see that we didn't include the last option. That is because we want the default to be Flux. If the user didn't choose any option, then it will be defaulted to the last one anyhow. And the last one, you will see that it is pointing to a Flux model. Now, if we run it, we will see that it's pointing us to Flux because we choose Flux anyhow. If we check each of these nodes, first is the one for LocalAI. So we need to choose here LocalAI. And then simply for the prompt, we'll need to pass the character and scene description like this. So we take first the character, then we do a space, for example, and then we pass the scene description. So we'll have both the character and then the scene description. And then we'll add best quality masterpiece to have good output. And then the vertical pipeline, and then the negative prompt this time. Similar thing for the ComfyUI nodes. I included here 4 nodes. That's because I want to provide the user with more options using different workflows for image generation. If we check the first one for SDXL, we can check the workflow here. So similar to before, we exported the workflow and we paste it here. The only difference is that we'll provide the prompt this time dynamically instead of just QtCut or statically. I'm also replacing here any new lines. That's because if the character text or scene description have any new lines, it will break the JSON format here, and then it will error out because it's not valid JSON anymore. And that's the result that we will have. So the same workflow, this time with the positive prompt. And then the negative prompt, as this is a ComfyUI workflow, we will pass the negative prompt to the negative text clip encode. And then the rest is the same. That's exactly the same thing for HiDream. It's just the workflow itself that is different. And similar thing for Illustrious and for Flux. So if we run this, and we can see that the image is being generated. Then we will need to save that image. We'll put it under /videos, and then the folder name that we created, /, and then we call it image, and then dash, and then we will use this expression here to retrieve the index of the loop. So it's the current index, it starts as 0, plus 1 to provide us with image 1 instead of image 0. And that will save our image as image-1. So let's execute that. We can check here in Visual Studio Code, and we will see that we have a folder and we have an image-1. We will need, of course, to repeat the process. So you see, once this is done, it goes back to the loop. And once we do that 6 times, we'll end up with 6 images from image-1 to image-6. And then the loop will exit, and that will take us to the next phase. That's what we will cover in the next video. Let's run the workflow. We'll put as superhero cat saving the world, put English as the language, and then we'll choose Flux for image generation. Click Run. Once the loop is processed the 6 visuals and transformed them into 6 images, saved the 6 images, we can already check it in Visual Studio Code and a video. We'll see the new folder created, and then we'll see the different images describing the story. By that, we have concluded the phase 2 of our process. So far, we generated the stories dynamically. We turned those stories into 6 images to visualize the story. And then for the next video, we will cover speech generation. We will also cover the transcription of those audios. And finally, we'll cover background audio music generation. So stay tuned for the next video. And if you want me to revise any of the items we covered today in a dedicated video, please let me know and I will cover it. Thanks a million for joining me in this journey, and see you next time. Enjoy.